They believed the American tank was a death trap. Every Panzer crewman knew the stories. The Sherman burned so easily that German tank crews called it the Tommy Cooker when fighting the British in North Africa, or the Ronson, after the cigarette lighter advertisement that promised it lights the first time, every time. By late 1944, this belief was not just propaganda. It was battlefield experience accumulated across 3 years of armored warfare in Europe. On the morning of March 23, 1945, near the town of Remagen in western Germany, a crew from the 2nd Panzer Division examined something they had not seen before. American forces had captured the Ludendorff Bridge over the Rhine 2 weeks earlier, and the fighting along the expanded bridgehead had been brutal. Among the debris of battle, abandoned after track damage from a German 88mm gun, sat an M4A3E8 Sherman tank. The German tank commander, an Oberfeldwebel who had fought in Normandy and survived the retreat across France, approached the disabled vehicle with caution born from experience. His own Panther tank was hidden in a tree line 300 meters away, its long-barreled 75mm gun trained on the American machine in case this was some kind of trap. But the Sherman was silent, its crew long gone. Its engine was cold. The track on the right side hung loose where the 88's impact had sheared the connecting pins. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. What he found when he climbed onto the hull and opened the commander's cupola changed his understanding of American tank design. The interior was not what he expected. There were features he had never seen in any tank, German or captured Allied vehicles, hatches in places that made no sense according to German design philosophy, ammunition stored in locations that seemed to defy every lesson learned from years of tank combat, fire suppression equipment that suggested the Americans had solved a problem German engineers still struggled with. He called his crew forward. They needed to see this. His gunner, who had served on Panzer IVs and Panthers, climbed into the turret. His loader examined the ammunition racks. His driver studied the escape hatches cut into the hull floor. Each man's reaction was similar, confusion followed by grudging recognition that the Americans had approached tank design with a different set of priorities. Priorities that placed crew survival ahead of other considerations. This was not the Sherman they thought they knew. This was the M4A3E8, a variant that had appeared in combat only in the final months of 1944. The designation meant little to German tank crews. They knew it as the Sherman with the wider tracks and the different suspension, the one that handled mud better than the earlier versions. But they had not understood how much had changed inside the tank. Changes that reflected American learning from years of combat loss reports and crew debriefings. The Oberfeldwebel had seen dozens of destroyed Shermans across France and Germany. He had watched them burn with their characteristic thick black smoke. He had seen American crews bail out frantically when German guns found their mark. He had assumed, as did every German tanker, that the Sherman's reputation for catching fire was inherent to its design, an unfixable flaw that came from American industrial mass production, prioritizing quantity over quality. What he discovered in that captured M4A3E8 near Remagen challenged that assumption. The Americans had not ignored the problem. They had solved it. And the solution was elegant, practical, and effective in ways that German tank design had not achieved. The German approach to tank design in 1945 rested on principles developed over 6 years of continuous warfare. Those principles emphasized firepower and armor protection above crew comfort or ease of escape. This was not accidental. It reflected a specific military philosophy about armored warfare that had been validated by years of success, then gradually undermined by the realities of industrial attrition. When Germany invaded Poland in September 1939, Its panzer divisions were equipped primarily with Panzer and Panzer II light tanks, supplemented by Czech-designed Panzer 38T vehicles. These were adequate against Polish cavalry and light fortifications, but German commanders already understood they needed heavier, more capable machines. The Panzer III with its 50mm gun and the Panzer IV with its short-barreled 75mm gun represented the core of German armored strength by 1941. These tanks reflected design priorities that would persist throughout the war: thick frontal armor to survive enemy fire, powerful guns to destroy enemy tanks at long range, excellent optics to identify and engage targets before being spotted, mechanical reliability to maintain operational tempo during deep penetration operations. Crew survivability was considered, but it was not the primary design driver. German tanks had escape hatches. The Panzer Vorschuss had a large hatch on the turret roof for the commander, a hatch for the loader, and hull hatches for the driver and radio operator. But these hatches were designed for normal entry and exit, not emergency escape. They were large enough to climb through when time permitted, not optimized for rapid evacuation when the tank was burning. German ammunition storage followed logical principles. Place the rounds where the loader can reach them easily. Store them in racks that keep them organized and prevent them from shifting during movement. Protect them with whatever armor can be spared without compromising the tank's fighting capability. The reality was that armor-piercing rounds, striking a tank, often penetrated the fighting compartment. When they did, any ammunition stored in that compartment was vulnerable to secondary detonation. German tankers knew this risk. They accepted it as inherent to armored warfare. When a Panzer IV or Panther was hit by an enemy round that penetrated the armor, the crew had seconds to escape before ammunition cooked off. Tank commanders drilled their crews on emergency evacuation procedures. Driver, out through your hatch. Radio operator, follow the driver. Gunner and loader, out through the turret hatches. Commander, ensure everyone is out, then evacuate last. In practice, emergency evacuation was chaotic and often lethal. A penetrating hit created blast overpressure inside the cramped fighting compartment. Crew members were stunned, wounded, or killed instantly. Smoke filled the interior within seconds. Flames followed if fuel lines or hydraulic fluid were ignited. The crew members who could move had to navigate through darkness and smoke to find their hatches, open them against possible damage that had jammed the mechanisms, and pull themselves through while possibly injured. German tank losses in Russia demonstrated the brutal mathematics of crew survival. In the initial invasion in 1941, German Panzer divisions advanced hundreds of kilometers, destroying thousands of Soviet tanks. But German tank losses were also significant, not from combat alone, but from mechanical breakdown in the harsh Soviet environment. Tanks that were damaged or immobilized were often destroyed by their own crews to prevent capture, following standing orders. By 1942 and 1943, as Soviet tank production increased and Soviet crews gained experience, German tank losses mounted. The introduction of the Soviet T-34 with its sloped armor and 76mm gun created problems for German Panzer III and the 14 crews. The T-34's armor was difficult to penetrate at normal combat ranges. Its gun could penetrate German tanks reliably. German responses included upgrading the Panzer IV with a long-barreled 75mm gun and developing new heavy tanks, the Panther and Tiger. The Panther tank represented German armor design philosophy at its peak. Development began in 1942 as a direct response to the T-34. German engineers studied captured Soviet tanks, measuring armor thickness, examining the sloped armor geometry, testing the suspension system. They created a tank that incorporated the best features of the T-34 while maintaining German standards for optics, fire control, and crew ergonomics. The Panther that entered production in 1943 weighed 45 tons, mounting a 75mm KWK 42L70 gun that could penetrate any Allied tank at combat ranges. Its frontal armor was 80mm thick, sloped at 55 degrees, providing effective protection equivalent to approximately 140mm against armor-piercing shot. The design was formidable, arguably the best medium tank of World War II in terms of firepower and protection. But the Panther had problems that reflected broader issues in German tank production. It was mechanically complex, requiring skilled labor and precision manufacturing that Germany's war economy increasingly could not provide. Early Panthers suffered from transmission failures, engine fires, and final drive breakages. The tank was over-engineered in some areas and underdeveloped in others, rushed into production before adequate testing could identify and fix design flaws. Crew survivability in the Panther was not significantly better than in earlier German tanks. The fighting compartment was larger than in the Panzer IV, giving the crew more working space, but ammunition was still stored in racks along the hull sides and in bins on the turret floor. A penetrating hit could ignite this ammunition, and the crew's chances of escape depended entirely on how quickly they could react and whether the hatches were still operable after the impact. German tankers developed their own informal modifications to improve survival chances. Some crews stored fewer rounds than authorized, keeping only the ammunition they expected to need for immediate combat and leaving extra space in the fighting compartment. Others positioned fire extinguishers in easily accessible locations, though these were often ineffective against fuel fires or ammunition detonations. Experienced commanders kept their hatches partially open during combat when tactical situation permitted, accepting the risk of small arms fire or shell fragments in exchange for easier emergency escape. The Tiger WWII and Tiger II heavy tanks represented German thinking about armor at its most extreme. Massive vehicles mounting 88mm guns, protected by armor that could withstand most Allied anti-tank weapons at normal combat ranges. The Tiger WWII weighed 56 tons. The Tiger II weighed 69 tons. Both were impressive fighting machines when they worked, but both were mechanically unreliable and consumed fuel at rates that Germany's shrinking petroleum reserves could not sustain. Crew survivability in the Tiger tanks was theoretically better due to thicker armor that was harder to penetrate, but once penetration occurred, the results were catastrophic. The massive 88mm ammunition rounds stored in the fighting compartment would detonate with devastating force. The sheer size and weight of the Tiger tanks meant that if they were disabled, recovering them for repair was often impossible. Crews of immobilized Tigers had standing orders to destroy their vehicles to prevent capture, using demolition charges or setting fire to the interior after removing sensitive equipment like the gun sight and radio. By late 1944, German tank production was focused on building as many Panthers as possible while continuing limited production of Tigers and maintaining Panzer IV production to fill out armored divisions. German factories built approximately 6,000 Panthers during the war, along with roughly 1,400 Tiger I's and fewer than 500 Tiger II's. These numbers seem substantial until compared to Allied production, particularly American output. German tank crews fighting in the West in late 1944 and early 1945 faced a specific tactical problem. Allied air superiority meant that German armor could rarely move during daylight without risking attack from fighter bombers. Allied artillery was devastating and seemed unlimited in its ammunition supply. Allied tank numbers were overwhelming, allowing American and British forces to accept losses that would cripple German units and continue attacking. The German tankers examining that captured M4A3E8 near Remagen in March 1945 understood these realities. They had fought against Shermans across France and into Germany. They knew the Sherman's weaknesses, its thin side armor, its tall silhouette, its tendency to burn when hit. They knew the Sherman's strengths, its reliability, its gun stabilization that allowed firing while moving, its sheer numbers. What they did not know, until they looked inside that particular tank, was how much American design priorities had evolved in response to combat experience. The M4A3E8 Sherman that sat disabled near Remagen represented the culmination of American learning from 3 years of armored combat. The designation broke down into specific meaning. M4 indicated the basic Sherman design. A3 specified the variant equipped with a 4 GAA V8 gasoline engine producing 500 horsepower. E8 denoted the horizontal volet spring suspension system, wider tracks, and associated modifications that distinguished this version from earlier Shermans. American tankers called it the Easy 8 from the E8 designation. It had entered combat in December 1944 during the Battle of the Bulge, though in limited numbers. By March 1945, Easy 8s were reaching armored divisions in increasing quantities, gradually replacing the older 75mm gun Shermans that had formed the backbone of American armored forces since Normandy. The German crew examining the tank would have immediately noticed the suspension. Earlier Shermans used vertical volet spring suspension, with the springs mounted vertically inside armored housings on the hull sides. The Easy 8 used horizontal volute springs mounted horizontally, paired with wider tracks. The tracks measured 23 inches wide compared to 16.5 inches on earlier models. This seemingly minor change had significant effects on mobility, particularly in mud and soft ground where narrow tracks caused earlier Shermans to bog down. But suspension improvements were evolutionary, not revolutionary. German tanks had excellent suspension systems. Panther's interleaved road wheel system provided superior weight distribution and a smooth ride, though it was prone to clogging with mud that would freeze in winter conditions. What interested the German tank commander was not the suspension, but what he found when he opened the hatches and looked inside. The commander's cupola on the Easy 8 was standard for late-war Shermans, a rotating structure with 6 vision blocks providing all-around visibility. German tank commanders appreciated good optics, and they recognized quality when they saw it. The cupola could rotate independently of the turret, allowing the commander to scan for threats while the gunner remained focused on a target. This was similar in concept to German cupola designs, though executed differently. Below the cupola, inside the turret, the German gunner noticed the ammunition storage immediately. The 76mm rounds were not stored in open racks along the turret walls, as in German tanks. They were in armored bins, surrounded by liquid. Water jackets enclosed the ammunition containers, creating a barrier between the rounds and the fighting compartment. This was wet stowage, a modification introduced on American tanks in early 1944, after analysis of combat loss reports revealed that ammunition fires were the primary cause of catastrophic tank losses. The concept was elegant. When an armor-piercing round penetrated the hull or turret, the impact generated heat and sparks. If this struck stored ammunition directly, the propellant could ignite, leading to catastrophic detonation of all stored rounds. Wet stowage placed a layer of water glycol mixture between the penetrating round and the ammunition. The liquid absorbed heat, provided additional mass that incoming projectiles had to penetrate, and created a barrier that prevented sparks from reaching the propellant. American testing at Aberdeen Proving Ground in Maryland had demonstrated the effectiveness. Shermans without wet stowage, when subjected to penetrating hits in areas where ammunition was stored, experienced ammunition fires in approximately 60 to 80% of cases depending on the specific circumstances. Shermans with wet stowage experienced ammunition fires in approximately 10 to 15% of cases. The reduction was dramatic, verified through repeated testing and confirmed by combat loss analysis from units in Europe. The German loader examining the ammunition bins understood the implications immediately. German tanks stored their ammunition in metal racks, sometimes with thin sheet metal separators between rounds, but nothing approaching the protection of wet stowage. When a Panzer IV or Panther was hit, if the round penetrated near ammunition storage, the crew knew they had seconds to escape. The wet stowage system in the EZ-8 suggested American crews had minutes, perhaps longer, before a fire became unsurvivable. But wet stowage was only part of the story. The German crew found additional features that revealed American design priorities. In the hull floor, beneath the driver and assistant driver positions, were large escape hatches. These were not standard entry hatches. They were emergency exits, designed specifically to allow crew members to bail out quickly if the tank was hit and the normal hatches were blocked or jammed. Each escape hatch measured approximately 22 inches by 26 inches, large enough for a man to squeeze through even while wearing combat gear. The hatches opened downward, hinged at the front edge, secured by quick-release latches that could be operated in darkness or smoke. The concept was simple but profound. If the tank was hit and fire broke out, crew members in the hull could drop through these hatches and escape underneath the tank, then crawl out from beneath the vehicle away from enemy fire. German tanks had no equivalent feature. The Panzer IV had hull hatches for the driver and radio operator, but these were designed for normal entry and exit, not emergency escape. They were located on the front glacis plate, meaning crew members exiting through them would be exposed to enemy fire. The Panther had similar limitations. The Tiger tanks, with their thick armor and heavy hatches, offered even fewer emergency escape options. The German tank commander stood in the turret of the captured EZ-8 and reassessed everything he thought he knew about American tank design. This was not the hastily built, quantity over quality machine he had been told to expect. This was a tank designed with systematic attention to crew survival based on empirical analysis of combat losses. He had read intelligence reports about American industrial capacity. The numbers were staggering, almost unbelievable. American factories produced thousands of tanks per month, while German production struggled to reach hundreds. He had assumed this massive output required simplification, reduction in quality, acceptance of higher failure rates. But examining the EZ-8's interior revealed something different. The Americans had achieved mass production while simultaneously incorporating sophisticated safety features that German tanks lacked. The fire suppression system reinforced this assessment. Mounted in the engine compartment was an automatic fire extinguisher system using carbon dioxide. If engine temperature exceeded safe limits or if fire was detected, the system discharged automatically, flooding the engine compartment with CO2 to smother flames. German tanks had manual fire extinguishers, small bottles mounted inside the fighting compartment that crew members could use to fight small fires. The automated system in the Sherman represented a higher level of engineering integration. The German driver examined the hull escape hatches more closely, operating the quick-release mechanism. It functioned smoothly despite the tank having been in combat. The design was foolproof, requiring only thought that the crew member pull a lever and push the hatch open. In darkness or smoke, when panic could prevent crew members from executing complex procedures, this simplicity could mean the difference between escape and death. His own Panther had no such feature. If the Panther was hit and fire broke out, he had one exit, through the front hull hatch that exposed him to enemy fire as he climbed out. If that hatch was jammed by damage to the hull structure, he had no alternative escape route. He would die in the tank. Every German tanker knew crew members who had died this way, trapped in burning vehicles, unable to escape through damaged hatches. The contrast forced recognition of an uncomfortable truth. American tank designers had prioritized crew survival in ways that German designers had not. This was not because German engineers were incompetent or uncaring. It reflected different design philosophies driven by different strategic circumstances. Germany needed tanks that could win engagements against superior numbers through superior firepower and armor protection. America needed tanks that could win campaigns through sustainable operations, which required keeping experienced crews alive to fight again. The German gunner, who had served on Panzer IIIs before transitioning to Panthers, understood the implications for combat effectiveness. A tank crew's capability increased dramatically with experience. A crew that had fought together for months learned to function as a single organism, with each member anticipating the other's actions. The commander knew his gunner's capabilities and limitations. The gunner understood the commander's tactical preferences. The loader learned the rhythm of combat, knowing when to have rounds ready. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Experienced crews survived longer because they made fewer mistakes. They recognized dangerous situations earlier. They used terrain more effectively. They maintained their vehicles better. But experience meant nothing if the crew died in their first serious engagement. German armored divisions in late 1944 and early 1945 were increasingly filled with inexperienced crews because experienced crews had been killed at rates that training could not replace. The wet stowage and escape hatches in the EZ-8 addressed this problem directly. Crews that survived hits because ammunition didn't detonate immediately could bail out and live to crew another tank. This was force multiplication through crew preservation. The Americans were not just building more tanks. They were keeping the crews alive to use them effectively. The German tank commander thought about his own crew. His gunner had been with him since Normandy. His loader joined the crew in August 1944, after the previous loader was killed when their Panther was hit by a British 76mm gun. The round had penetrated the turret side armor, striking the loader directly. He died instantly. The commander, gunner, and driver escaped through their hatches before ammunition cooked off. They were assigned a new loader within 3 days, a young man fresh from training who had never seen combat. The examination of the EZ-8 continued as the German crew looked at other details that revealed American thinking. The gun was a 76mm M4A3E8, a significant improvement over the 75mm guns that armed most Shermans earlier in the war. The longer barrel and higher muzzle velocity gave the gun better armor penetration, though it still could not reliably penetrate a Panther's frontal armor at normal combat ranges. But the gun was stabilized in the vertical axis, allowing the Sherman to fire accurately while moving. The German gunner tested the mechanism, traversing the turret and elevating the gun. The hydraulic system functioned smoothly, even though the tank had been sitting disabled for days. German tanks used manual traverse for their turrets, requiring the gunner to physically crank a hand wheel to rotate the turret. This worked well when the tank was stationary, but became difficult when the tank was moving over rough ground. The powered traverse on the Sherman, combined with the gun stabilization, gave American tanks a tactical advantage in fluid engagements. They could fire effectively while maneuvering, forcing German tanks to stop to return accurate fire. In the bocage country of Normandy, where combat ranges were often under 500 meters and first shot often determined the outcome, this capability had proven valuable. The radio equipment revealed another disparity. Every Sherman had a radio. The EZ-8 was equipped with an SCR-528 set, allowing communication between tanks and with infantry and artillery. The radio had multiple preset frequencies, allowing rapid switching between command nets and fire support nets. German tanks also carried radios, but in Panzer companies only the command tanks had full radio capability. Platoon tanks often had receivers but limited transmission capability, forcing them to rely on visual signals for coordination. The German radio operator examined the American set with professional interest. The frequency range and channel capacity exceeded German tactical radios. More significantly, the radio appeared to be standard across all American tanks, suggesting an industrial capacity that could equip every vehicle with full communications equipment. This was force multiplication through coordination, allowing American units to mass fires, call for artillery support, and adapt to changing tactical situations faster than opponents who relied on visual signals or limited radio communications. The German crew spent over an hour examining the EZ-8, taking notes, discussing what they found. The tank commander knew he needed to report this to higher headquarters. Not that it would change anything at this point in the war. Germany's industrial capacity was shattered by bombing and lack of raw materials. Even if German engineers wanted to incorporate wet stowage or hull escape hatches into new tank designs, the factories probably couldn't implement the changes. Production was focused on building anything that could fight. Quality and crew survivability features were luxuries Germany could no longer afford. But understanding the enemy's capabilities mattered for immediate tactical decisions. The EZ-8 was more survivable than earlier Shermans. Crews that would have died in older models might escape from this version. That meant American armored units would retain experienced crews longer. That meant future engagements would be against increasingly skilled opponents. That meant the already unfavorable odds German tankers faced would continue to worsen. As the German crew prepared to leave the captured tank, the commander took one last look at the interior. The craftsmanship was evident throughout, from the welded seams to the painted instructions stenciled on equipment, to the systematic organization of tools and spare parts. This was not a crude machine rushed through production. This was an industrial product built to exacting standards, incorporating lessons learned from combat analysis, designed to maximize both fighting capability and crew survival. He thought about the propaganda he had heard throughout the war. American industry produced inferior weapons because Americans valued comfort over fighting ability. American tanks were soft, built for crews who lacked the hard warrior spirit of German soldiers. American equipment failed in harsh conditions because it was designed for peacetime luxury. Every part of this propaganda was contradicted by what he saw in the EZ-8. The Americans had built a tank that was not just adequate but sophisticated in ways that addressed real combat problems with practical engineering solutions. The contrast with German tanks was stark. Panthers and Tigers were formidable fighting machines when they worked, but they were mechanical nightmares plagued by breakdowns. They were difficult to maintain, requiring specialized tools and trained mechanics. They consumed fuel at rates that exceeded available supplies. They were too heavy for many bridges, forcing them to ford rivers or find alternative routes. And when they were hit, their crews died at rates that no amount of firepower or armor could justify. The report from the German tank commander reached 2nd Panzer Division headquarters within 2 days. It was consolidated with similar reports from other units that had examined captured American equipment. By late March 1945, German intelligence officers had compiled a comprehensive assessment of the M4A3E8 Sherman and its capabilities. The report acknowledged what frontline tank crews already knew. American tank design had evolved significantly, incorporating features that addressed crew survivability in systematic ways that German tanks lacked. The report circulated to higher commands but generated no operational changes. Germany's situation in March 1945 left no room for implementing new tank designs or modifying existing production. The Ruhr industrial region was encircled by American forces. Berlin was threatened from the east by Soviet armies that had pushed across Poland and into eastern Germany. Fuel shortages meant that tanks often sat immobile, unable to maneuver even when threats approached. Ammunition was rationed. Spare parts were nearly impossible to obtain. German tank crews continued fighting with the equipment they had. Panthers and Tiger IIs remained formidable when they could be fueled and maintained, but increasingly they were abandoned due to mechanical breakdown or lack of fuel rather than combat damage. The numerical disparity had become overwhelming. In the West, American and British forces fielded thousands of tanks supported by complete logistics systems. In the East, Soviet tank armies numbered their vehicles in the thousands, with T-34s produced in quantities that exceeded total German tank production for the entire war. For the German tank commander who had examined the EZ-8, the remaining weeks of the war involved a fighting withdrawal eastward. His Panther was abandoned on April 7, 1945, when the final drive failed and no replacement parts were available. The crew destroyed the tank with demolition charges to prevent capture, removing the breech block from the gun and the radio equipment before setting fire to the interior. They continued fighting as infantry until captured by American forces on April 21st. During interrogation, the commander spoke frankly about German tank capabilities and American equipment superiority. His comments were recorded in intelligence reports that circulated through American armored commands. He acknowledged that German tanks had better guns and thicker armor than Shermans, but emphasized that American advantages in reliability, crew survivability features, and overwhelming numbers more than compensated for any technical inferiority in firepower. He specifically mentioned the wet stowage and hull escape hatches as features that would have saved German lives if incorporated into Panzer designs. These assessments, compiled from multiple captured German tank crews, confirmed what American tankers had reported from their own combat experience. The EZ-8 was a significant improvement over earlier Shermans, not primarily in firepower but in survivability. Crews that might have died in earlier models survived hits in the EZ-8 because ammunition fires were less frequent and escape was easier when fires did occur. Statistical analysis supported these observations. Sherman losses in European combat from June 1944 through May 19. 45 totaled approximately 4,000 tanks destroyed or damaged beyond field repair. But crew casualties were disproportionately lower than vehicle losses, particularly for tanks equipped with wet stowage. A tank hit and destroyed might be a total loss, but if the crew survived, they could be assigned to a replacement tank within days. The industrial system could replace destroyed vehicles faster than training could replace dead crew members. German tank losses in the same period were approximately 3,000 vehicles, but crew casualties were proportionally higher. German tanks, when penetrated, burned more frequently because ammunition was not protected by wet stowage. Escape was more difficult because hull escape hatches did not exist. The combination meant that German armored divisions lost experienced crews at rates that could not be sustained. By March 1945, many German tank crews had less than 3 months of experience, facing Allied crews that often had 6 months to a year of combat experience. The psychological impact on German tank crews who recognized these disparities was significant. Combat effectiveness requires confidence in equipment. A tank crew that trusts their machine fights more aggressively, takes necessary risks, and maintains morale even under adverse conditions. But German tank crews in the final months of the war increasingly understood their equipment was inadequate not just in numbers but in fundamental design priorities. Fighting spirit could not overcome ammunition that detonated when hit, or hatches that trapped crew members in burning vehicles. The American approach to tank design that produced the EZ-8 reflected a broader military philosophy about industrial warfare. Equipment would be destroyed in combat. That was inevitable. The question was whether the industrial base could replace destroyed equipment faster than the enemy could destroy it, and whether crews could be preserved to operate replacement equipment effectively. The answers to both questions determined campaign outcomes more than individual weapon system performance. American tank production from 1942 through 1945 totaled approximately 50,000 Sherman variants of all types. This number exceeded combined German production of all tank types during the same period by a factor of approximately 4 to 1, but raw numbers understated the advantage, because American production included continuous improvement based on combat feedback. The wet stowage modification appeared on Sherman production lines in early 1944, within months of combat loss analysis identifying ammunition fires as the primary cause of catastrophic kills. The hull escape hatches were added based on crew requests and engineering studies of emergency egress under combat conditions. The 76mm gun was installed in response to reports that the 75mm gun had insufficient armor penetration against German heavy tanks. Each improvement was implemented rapidly, with modified tanks reaching combat units within weeks or months of the decision to incorporate the change. German tank development followed a different pattern. The Panther was designed in 1942 in response to the T-34, but production models did not reach combat units until mid-1943. Early Panthers suffered from mechanical problems that required months to identify and address. By the time reliable Panthers were available in quantity, the tactical situation had deteriorated to the point where even excellent tanks could not compensate for numerical inferiority and fuel shortages. The Tiger II, designed as the ultimate heavy tank with armor that could resist any Allied tank gun, entered production in early 1944. Only 489 were built before the war ended. The tank was mechanically unreliable, consumed fuel at unsustainable rates, and was too heavy for most bridges. Crews that received Tiger the Soyuz often found themselves unable to maneuver effectively due to fuel shortages or mechanical breakdowns. The theoretical superiority of the Tiger II's 88mm gun and heavy armor meant little when the tank could not reach the battlefield or broke down during movement. American tankers who fought against Panthers and Tigers respected these vehicles but did not fear them in the way German propaganda suggested they should. American doctrine emphasized combined arms operations. If a Sherman encountered a Panther, the Sherman crew could call for artillery support, airstrikes, or additional tanks to flank the German vehicle. American tank destroyers with 90mm guns could engage Panthers at ranges where they could penetrate the frontal armor. Infantry with bazookas could disable tracks or engine compartments, immobilizing the Panther for destruction by other weapons. The Easy 8 fit into this doctrine as an improved general-purpose tank, not as a specialized tank killer. Its 76mm gun gave it better capability against German armor than the 75mm gun, but it was not expected to win frontal engagements against Panthers or Tigers. Its wet stowage and escape hatches gave crews better survival odds when hit, which was more important than marginal improvements in armor penetration, because crew survival determined long-term combat effectiveness. Post-war analysis by American and British military historians examined the question of whether Allied tanks were inferior to German tanks. The consensus was that German tanks had better guns and thicker armor, but Allied tanks had better reliability, crew ergonomics, and were produced in quantities that made numerical comparisons meaningless. A Panther might be superior to a Sherman in a one-on-one engagement at medium range, but combat did not occur in isolated duels. Combat occurred in complex environments where artillery, air power, infantry, logistics, and numerical superiority determined outcomes. The German tank commander who examined the Easy 8 near Remagen understood this after the war when he had time to reflect on his combat experience. He had fought in one of the best tanks Germany produced, the Panther, crewed by experienced men who knew their jobs. They had destroyed numerous enemy tanks, accomplished their missions, and survived longer than most German tank crews in 1945. But they lost the war because individual superiority in tank design could not overcome systematic inferiority in industrial capacity, logistics, and design philosophy that prioritized crew survival. The moment when that German tank commander climbed into the captured EZ-8 and discovered wet stowage and hull escape hatches represented something larger than tactical intelligence gathering. It represented the collision between two fundamentally different approaches to industrial warfare. Germany had designed tanks to win engagements through superior performance. America had designed tanks to win campaigns through sustainable operations. The distinction mattered because wars are not won by individual battles, but by the cumulative effect of campaign-level operations sustained over months and years. A tank that could destroy two enemy tanks before being knocked out was impressive, but a tank that allowed its crew to survive being knocked out so they could fight again in a replacement tank was strategically more valuable. Germany could build excellent tanks, but could not replace them or their crews fast enough. America built adequate tanks, but could replace both vehicles and crews faster than they were lost. The psychological experience of German tank crews who recognized this disparity shaped their understanding of why Germany lost the war. Propaganda had told them that German technical superiority and fighting spirit would overcome Allied material advantages. Combat experience taught them that material advantages, when large enough, could not be overcome by technical superiority or fighting spirit. The crew survival features in the EZ-8 were not mentioned in propaganda on either side, but they represented the practical application of industrial capacity to real combat problems. After the war, surviving German tank crew members who emigrated to the United States or other Allied countries sometimes encountered Sherman tanks in museums or military displays. Their reactions, recorded in interviews and memoirs, consistently expressed respect for American engineering and industrial achievement. They acknowledged that German tanks were in some ways superior, but emphasized that the German approach to tank design had been strategically flawed. Building fewer, more complex tanks that could not be maintained or fueled in sufficient numbers was a failure of strategic thinking, not a failure of engineering capability. American tankers who served in EZ-8s and survived the war generally praised the tank's reliability and crew comfort features. They acknowledged that it was not the most powerful tank on the battlefield, but emphasized that it was available in quantity when needed. Mechanical problems were rare, and crews felt safer in it than in earlier Sherman variants. The wet stowage and hull escape hatches were mentioned frequently as features that saved lives, though often in understated ways that reflected the pragmatic attitudes of men who had survived combat. The EZ-8 continued in service after World War II, seeing combat in Korea, where its reliability and adequacy proved valuable against North Korean T-34-85s in the war's early months. Some variants remained in service with American reserve units and Allied nations through the 1950s and into the 1960s. The basic Sherman design, continuously improved from its introduction in 1942 through the end of production in 1945, represented American industrial capability applied to military requirements with systematic incorporation of combat lessons. The broader lesson from the story of German tankers discovering American crew survival features was about the relationship between industrial capacity and military effectiveness. Wars between industrial nations are won by the side that can sustain operations longer, replace losses faster, and adapt to changing conditions more effectively. Individual weapon system performance matters, but it matters less than the systematic integration of production, logistics, crew training and design philosophy that prioritizes sustainable operations over maximum performance. The German tank commander who examined that EZ-8 near Remagen on a cold morning in March 1945 learned this lesson in the most direct way possible. He saw physical evidence that American tank designers had solved problems German designers had acknowledged but not addressed. He recognized that the solutions were practical, effective, and implementable in mass production. And he understood that Germany had lost not just the war, but the industrial and philosophical competition that determined how wars between modern nations would be fought and won. That understanding, gained from examining wet stowage bins and hull escape hatches in a disabled enemy tank, was more valuable than any intelligence about gun penetration or armor thickness. It was recognition that the war had been lost, not on the battlefield alone, but in the factories, the design bureaus, and the strategic decisions about how to allocate limited resources across competing requirements. The Americans had chosen crew survival as a design priority. That choice, multiplied across thousands of tanks and hundreds of thousands of crew members, had helped win the war. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.